So today we're going to cover Chapter 8, Section 3, and we're going to learn how to prove triangles similar by SSS, which stands for side, 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 and SAS, which stands for side, angle, side. So the first theorem is called side, 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 or SSS, similarity theorem. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. So what we need to do now, instead of finding two congruent angle pairs, we need to make sure that all three sides simplify to the same ratio. In other words, to make sure that they are proportional. So this time they actually gave me a similarity statement so I can see the sides that match. But if they didn't, then what I would look for the smallest side in each triangle, put those together, then the next biggest one, and then finally the largest. But I could use my similarity statement to make sure that I get all of the sides and show that they're proportional. So I would match AB and DE. So AB is 8, DE is 4. Now, to put this in a statement of proportionality, we would put DE over AB. And then I would go to the next two letters, the BC with the EF, BC and EF. So EF over BC. And then finally the last, I would show AC and DF together. So DF and AC. Now I need to make sure, now I got to put the numbers in it and make sure they simplify to the same ratio. So the DE was 4, AB was 8, simplifies 1 to 2. For the EF, it's 3, BC was 6, simplifies 1 to 2. So far, so good. Soon as I would find a ratio or a fraction that didn't simplify to the same thing, I would stop and say that they're not similar. So DF is 5, AC is 10. This one also simplifies to 1 to 2 or 1/2. My scale factor of changing the triangle from ABC to DEF, the scale factor is the 1/2 or the 1 to 2. So understand the vocabulary. This right here, the three fractions with the variables, again, this is called the statement of proportionality. So when I ask for this on the quiz, understand this term. And when I ask you to write a similarity statement, this is what's down pictured here at the bottom. The triangle ABC is similar to triangle DEF. And then the scale factor is the simplified ratio. Now, if they would have said, give the scale factor from DEF to ABC, then I would have flipped it 2 to 1, and the scale factor would have been 2. So just watch the order that they give you that statement. So because I showed all three sides are proportional, I would be using the shortcut SSS or side, side, side. The next shortcut is called SAS or side, angle, side. Notice the variable A is in between the two S's, indicating that it has to be the included angle. So the SAS similarity theorem states that if an angle of one triangle is congruent to an angle of the second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So in here, it's hard to see though, but it's showing that angle A and angle D are congruent. So we would have to find the included angle with congruency marks. And then we have to check to see if the sides are proportional. Again, when they give you a similarity statement, we can use it. So I would match AB with DE. AB is here, DE here. So the statement of proportionality would be that DE is proportional to AB. We would have to show that 4 over 8 and what it simplifies. And then when I take the next two letters, the BC, no, I'm going to do the AC with the DF. So DF is proportional to AC, because I don't have numbers on BC or EF. So then here I would show that 8 over 4 over 5 over 10 simplifies 1 to 2. So I could show that these two triangles are similar by using side, angle, side, because I have the congruent angles of A and D, and I just showed that the two sides, including that angle, are proportional. So this would be using side, angle, side. This would be the scale factor again of changing triangle ABC into DEF. The next slide just has a summary of the 3 ways of proving triangles similar. There are only 3 ways, so this is it. Remember back when we did the triangle congruence, there were 5. So this only has 3. It's angle, angle, side, 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 and side, angle, side. So let's try some examples. Now, notice no picture was provided. It usually will be beneficial or helpful if you can give yourself a visual. Now also notice in example 1A, I didn't tell you which side to put the 4, 5, and 7, or the 16, 20, or 28. So I'm gonna go ahead and do that. On the quiz, it'll be like 1B where I tell you the length of AB or the length of AC. So let me go ahead and draw the picture for 1A. And ABC is the smaller triangle. It's got smaller sides. So A, B, C, and I'm gonna put 4 on side AB, and then I'm gonna put 5 here and 7 here. And then next I'm gonna draw the XYZ. This has 28 here, 16 here, and then 20. Now, they just want us to know, are these two triangles similar? They did not give me a similarity statement, so this is where I'm gonna look at how big the numbers are. So in order to figure out what matches, from the ABC triangle, I can see my smallest number here out of the 4, 5, and 7 is the 4. And then I'm going to look for the smallest number in the XYZ triangle, which is the 16. So I'm going to show that XY is going to be proportional to AB, because this one has 16 and 4, the two smallest numbers, 4 to 1. Then I'm going to look for the next biggest side. In the ABC, it's the 5, and the XYZ, it's the 20. So I'm going to show that YZ is proportional to BC. So 20 over 5 still simplifies 4 to 1. So far, so good. And now let's do the last one, the biggest number with the biggest number here. So the XZ proportional to AC. XZ is 28, AC 7, 4 to 1. So because all 3 sides are proportional and they simplify to the same ratio, I could say that these triangles are similar by using side, 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 and my similarity statement could be that triangle ABC is similar to XYZ. This is your similarity statement. Remember, your statement of proportionality are these 3 ratios. Now, the next one, they gave us where to put the numbers. So let me go ahead and draw the 2 triangles for 1B. I'm going to come over here to the side. So for 1B, notice this time the ABC is the bigger triangle, and the XYZ is the smaller. But this time they told me AB is 2, AC is 5, BC 6, and then XY is 2.5, YZ is 2, and XZ is 3. Also, what they gave me was a similarity statement here to check. So they want me to check to see, is triangle ABC similar to XYZ? So So let me go in the order that it's listed. So I'm going to check to see if AB is proportional to XY and set up all the sides. So AB here is 2, XY is 2.5. So XY over AB, that'll be 2.5 over 2. You can't have a decimal and a fraction, so I need to simplify it. What I can do is multiply the numerator and the denominator by 10 and make this 25 over 20, which reduces to 5 to 4. Now let's look for the next two letters, the BC with the YZ, 6 and 2. So BC, let's do XY or YZ, BC. This time for the blue, I end up getting 2 over 6, simplifies 1 to 3. Soon as you find two fractions that are not equal, you're going to stop and say that these two triangles are not similar because the sides are not proportional. They do not simplify to the same ratio. And I knew nothing about angles, so I couldn't go back and even try to do anything with an angle. So for example 2, they're giving me that this triangle XYQ right here is similar to XZP. So let me go ahead and redraw these so I can find the corresponding parts. So X, Z, P, and then I have the XYQ. Now remember, when we have similar triangles, and that's what they told us here, I know that it has the corresponding angles that are congruent. So X and X are the same, so X will be congruent to X. Then I also know Y and Z, the second letters, are congruent. And then finally the last, the Q and the P. Now, what it wants me to do is try to check to see, is this triangle XPQ, so this little one at the top, is it similar to the large triangle, the XZY? So the whole thing. So let me redraw these. So I have XPQ, and then I have the whole big one, the XYZ. So based off of the red and the blue, I know that angle X and angle X are congruent. I also know P and Q are congruent. And then Y and Z. Now notice I don't have like corresponding congruent angles, two pairs, in the purple and the orange. I only have angle X and angle X. However, what I do see is that both the purple and the orange triangles are isosceles. So I could use my base angles converse, and I can state that XP is going to be congruent to XQ, and then the same thing here. So I have two isosceles triangles, which are going to be congruent, not congruent, they are going to be similar because I have angle X congruent to angle X, and then if I have two sides that are the same, then I already know that their ratios are going to be the same. So even if I just add random numbers and put the same number on each of these, because they're congruent, and maybe put an 8 here, I can show from my statement here that the first two letters, XP and XZ, so if I do XZ over XP, XZ is this 8 and XP is 5, so 8 over 5. And then if I do these two, which are going to be the XQ, the first and the last, with the first and the last here. If I do XY, over XQ, it still is 8:5. Same ratio. So I could say, yes, this statement is true by using side, angle, side. Because I have a side, the angle, and the side that are, sides are proportional, and the included angle is congruent. So for the last one, 3 different pictures. Again, remember, we don't have postulates in our book, so they're all theorems. So the answer is either going to be angle, angle, side, 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 or side, angle, side, or not similar. So let's go ahead and take a look at example 3A. So the triangles I'm going to try to show are similar are going to be this little one on the top, the ADE, and they gave me that angle D here is 80, and then I'm going to compare it to the whole thing, the ABC. And angle B here is also 80. So now, I either need to find proportional sides or 2 congruent angle pairs. I don't have any numbers on my sides, but what I do have is that they both share angle A. So I could say that angle A is congruent to angle A, and then I've got the 80s that are congruent. So I do have 2 congruent angle pairs. So I will say, yes, these are similar using angle, angle, and my similarity statement could be that triangle ABC is similar to triangle ADE. Because A and A match, B and D match, and lastly, C and E match. For example 3B, again, I'm going to pull them apart. So the little one in the top. So I'm going to look at CDE. And it's got a length of 6 and 10. And then I'm going to do the whole big one, the ABC.
I have a question.
Okay, so here, A, B, C. Now, notice to find the length of this, I have to add 3 plus 6. So this will have a length of 9. And then over here, to find the length of BC, I'm going to add 10 plus 5, and it has a length of 15. So now what I'm going to do is I'm going to look for the sides to be proportional. So what I could do is check that BC is proportional to the biggest number here, which is 10. So I could do CE. So 15 over 10 simplifies 3 to 2. Then I could do the smallest number. So I would check to see that AC is proportional to CD, 9 over 6, 3 to 2. Notice they also both have angle C. So angle C is congruent to angle C by reflexive. So I do have enough information to prove that these 2 triangles are congruent because I have the 2 proportional sides and the included angle as congruent. So by using side, angle, side, I could state that ABC is similar to triangle DEC. If you would have preferred to put the smaller triangle, list those first. And again, the order doesn't matter as long as everything is in the right match. So like, for example, you could have said CDE similar to CAB because C and C match, A and D, and E and B. And then the last example, this little one here, the KLM. Three, 5, and 6, and then the whole thing, KNO. This is 6, 10, Now, for this KN, we have to add 6 plus 6, and it's 12. Now, notice I don't have any information about any angles. So obviously, I'm going to need to check side, side, side. So I don't have a statement. So I'm going to match the size of the sides. So I'm going to look for the smallest number. It's the 3. And it's going to match with the smallest number here. This will help when they're not sitting the same way. So what I could do is show that KO and KL. And this would be 6 over 3, 2 to 1. Then I can go and match the next biggest side, which is the 5 and the 10. So here I could put NO with LM. So NO is 10, LM is 5, 2 to 1. Good so far. And then now lastly show the biggest side, the 12 and the 6. So that'll be KN with KM, 12 to 6, 2 to 1. So because they all are proportional, and this is my statement of proportionality, and this is my scale factor, 2 to 1 or 2, going from the small to the big, I can state that triangle KLM is similar to triangle KON.